Welcome to our channel with new interesting episode. The unfolding events at Yellowstone National Park have thrust the world into a state of heightened alert and urgency. Recent seismic activity and geothermal changes have prompted officials to issue an unprecedented evacuation order, fearing the imminent eruption of the supervolcano lurking beneath Yellowstone. This decision comes after weeks of escalating signs of unrest, raising concerns among scientists and emergency management authorities alike. Yellowstone, renowned for its natural beauty and geothermal wonders, is now the focal point of a potential disaster of monumental proportions. The supervolcano beneath Yellowstone is exhibiting alarming signs. The ground is swelling in certain areas, a phenomenon known as uplift, caused by the accumulation of magma and gases beneath the Earth's surface. Recent weeks have seen up to 6 inches of uplift in some areas, a stark indicator of the pressure building beneath the surface. Accompanying the seismic activity are significant changes in Yellowstone's geothermal features. The park's iconic geysers, hot springs, and fumaroles, steam vents that dot the landscape, have all shown increased activity. Geysers like Steamboat Geyser, known for sporadic and powerful eruptions, have become more frequent and intense, reaching heights of up to 300 feet. Hot springs, typically stable in their behavior, have exhibited rising temperatures and changes in color, signs of chemical alterations due to the influx of new gases and minerals from beneath. Fumaroles, releasing steam and gas into the air, have intensified their output, further indicating heightened activity below the surface. In response to these ominous developments, officials have taken decisive action. Evacuation orders have been issued for the surrounding areas, spanning parts of Wyoming, Montana, and Idaho. The scale of this evacuation is unprecedented, covering nearly 3,500 square miles of territory. Coordination among state, local, and federal agencies has been critical to ensure the orderly departure of residents and visitors alike. Evacuation routes have been established, shelters prepared, and emergency responders mobilized to assist those in need. The decision to evacuate was not made lightly. It followed weeks of intensive monitoring and consultation with volcanologists and emergency management experts. The Yellowstone Volcano Observatory, YVO, tasked with monitoring volcanic activity in the region, initially raised the alert level from normal to advisory as signs of unrest became apparent. Subsequent increases in seismic and geothermal activity prompted further elevation to a watch level, signifying a heightened risk of eruption. Understanding the gravity of the situation requires delving into the scientific underpinnings of Yellowstone's supervolcano. A supervolcano, as defined by its classification on the Volcano Explosivity Index, VEI, has erupted with a magnitude of 8 or higher, ejecting more than 1,000 cubic kilometers of material. Yellowstone's supervolcano fits this classification, making it one of the most potent geological features on Earth. The Yellowstone caldera, primarily located in northwestern Wyoming, is the largest volcanic system in North America. Spanning approximately 3,500 square miles, the park's geological significance is matched only by its potential for catastrophic eruption. Over the past 2.1 million years, Yellowstone has experienced 3 major eruptions, each leaving an indelible mark on the landscape and global climate. The most recent of these eruptions, the Lava Creek eruption around 631,000 years ago, ejected an estimated 1,000 cubic kilometers of volcanic material. This event, which formed the Lava Creek Tuff and spread ash across vast regions of North America, provides a sobering reminder of Yellowstone's eruptive potential. The impact of such eruptions extends far beyond the immediate vicinity of the park, affecting ecosystems, climate patterns, and human populations on a global scale. Central to understanding Yellowstone's supervolcano is its massive magma chamber, a reservoir of molten rock located several miles beneath the Earth's surface. This chamber, spanning approximately 60 kilometers in length, 30 kilometers in width, and up to 10 kilometers in depth, contains both solid and partially molten rock. Recent advancements in seismic imaging have revealed a more detailed structure, showing 2 interconnected reservoirs within the chamber. The upper reservoir consists predominantly of solid rock with pockets of molten material, while the deeper reservoir contains more fully molten rock. The presence of gases within the magma, including water vapor, carbon dioxide, and sulfur dioxide, increases pressure within the chamber. As magma accumulates over time, this pressure builds, creating conditions that could eventually trigger an eruption. Seismic activity and magma movement are primary triggers for volcanic eruptions. Earthquakes in the Yellowstone region, result of tectonic movements and magma shifts beneath the surface, can fracture the Earth's crust, providing pathways for magma to ascend. Scientific modeling of potential eruption scenarios offers insight into the range of possible outcomes. Minor events, such as hydrothermal explosions, involve localized bursts of steam, water, mud, and rock. These events, though destructive within their immediate vicinity, typically have limited widespread impact. A more severe scenario, however, could involve a moderate volcanic eruption, ejecting over 1,000 cubic kilometers of material and creating pyroclastic flows. Pyroclastic flows, fast-moving currents of hot gas, ash, and volcanic rock, can travel at speeds of up to 700 kilometers per hour, 450 miles per hour, and reach temperatures exceeding 1,000 degrees Celsius (1,830 degrees Fahrenheit). These lethal flows obliterate everything in their path, causing devastation within a radius of up to 100 miles from the eruption site. The immediate area around Yellowstone, including parts of Wyoming, Montana, and Idaho, would face catastrophic impacts, with infrastructure, wildlife, and communities at risk of total destruction. The consequences of a Yellowstone supervolcano eruption extend well beyond the immediate vicinity of the park. The eruption would produce an enormous ash cloud, composed of fine particles of rock, minerals, and volcanic glass. This ash would be ejected high into the atmosphere, darkening the skies and blanketing the landscape with a thick layer. The heaviest ash fall would occur within a 500-mile radius of the eruption site, affecting states such as Wyoming, Montana, Idaho, and Colorado. Ashfall poses numerous hazards to human health and infrastructure. Inhalation of volcanic ash can cause respiratory issues, particularly for individuals with pre-existing conditions such as asthma or bronchitis. The fine particles can irritate the eyes and skin, contaminate water supplies, and disrupt air travel by clogging air filters and coating runways. Pyroclastic flows, meanwhile, pose an immediate threat to life and property, incinerating everything in their path and leaving behind a landscape transformed by volcanic devastation. Lava flows, though slower moving than pyroclastic flows, present significant challenges for affected communities. These flows would destroy buildings, roads, and infrastructure, altering the landscape permanently and hindering recovery efforts. Human casualties would be inevitable in the event of an eruption, particularly for those within the immediate vicinity of the eruption site. Emergency services would be overwhelmed, and evacuation efforts would be complicated by the rapid onset of volcanic hazards. Environmental impacts would be profound as well. The eruption would lead to the immediate loss of wildlife and vegetation in the affected areas, with entire ecosystems destroyed by pyroclastic flows and lava. Forests, rivers, and lakes would be contaminated by ash and chemical pollutants released during the eruption. Long-term effects on the environment would include soil degradation, changes in water chemistry, and the potential for secondary hazards such as landslides and flooding. In conclusion, the ongoing crisis at Yellowstone National Park underscores the urgent need for preparedness and vigilance in the face of natural disasters. The supervolcano beneath Yellowstone represents a potent geological force, capable of catastrophic eruptions with far-reaching consequences. Continued scientific research and monitoring are essential to understanding and mitigating the risks posed by Yellowstone's supervolcano, ensuring the safety of communities and ecosystems vulnerable to its potential impacts. When a Yellowstone supervolcano erupts, the immediate focus shifts to survival. Recovery efforts must quickly establish shelters for displaced populations and deliver emergency supplies like food, water, and medical equipment. The economic impact is profound, with billions of dollars in damage and countless livelihoods lost. Recovery could span years, involving the rebuilding of infrastructure, restoration of services, and environmental rehabilitation. The psychological toll is significant, with trauma and mental health issues emerging from the devastation. Beyond the immediate aftermath, the broader consequences ripple globally. The eruption unleashes a massive ash cloud that threatens air travel. Composed of abrasive rock and glass particles, volcanic ash can severely damage aircraft engines, as demonstrated in past eruptions. Flight cancellations would cascade from North America across continents, potentially grounding flights for weeks or months. Climate effects are severe and enduring. The eruption releases sulfur dioxide into the atmosphere, forming sulfate aerosols that reflect sunlight and cool the Earth's surface. Agriculture suffers with reduced sunlight and lower temperatures, risking crop failures and food shortages worldwide. Livestock face feed shortages, exacerbating food crises, especially in vulnerable regions. Studying past volcanic events like Mount Pinatubo in 1991 and Tambora in 1815 offers insights into potential outcomes. Pinatubo's eruption caused a global temperature drop and significant destruction, evacuating over 250,000 people and costing billions in damages. Tambora's 1815 eruption led to the year without a summer, devastating crops and causing widespread starvation. Preparedness is crucial. Government agencies and the scientific community monitor Yellowstone with seismographs, GPS, and satellite imagery to predict eruptions. Evacuation plans are detailed, aiming to safeguard lives from pyroclastic flows and ashfall. Emergency response teams, including firefighters and medical personnel, train rigorously for rapid deployment. Modern technology, like alert systems and social media, ensures timely dissemination of evacuation orders and safety instructions. Residents are urged to stay informed and prepare emergency kits with essentials. During an eruption, staying indoors protects against ashfall and airborne debris, with clear guidelines on when it's safe to resume normal activities. Thanks for watching our channel. Keep watching and stay tuned for more interesting videos. Have a good day.